Hey guys, it's Fen. In this video we're going to do the calculations because we have done the genomes and the mutations and so on, but we haven't done any calculations whatsoever. So basically, well, we can mutate stuff, but there's no way we can actually use them. So that's what we're going to do in this video, and it's going to be a little bit complicated, and it's going to be a lot of code that has already been coded. So it's not really beautiful code, but it's I would say it's very structured. So let's create a new package and call it calculations. And we're going to create a new node class, a new connection class, and a calculator class. Basically, the node and the connection are really the same class, but we want to separate them. So let's create the connection first, and I'm going to call it just connection, not connection gene. So connection. And we can go into the genome, into the connection gene, and basically just copy all the code except the hash code and the equals thing. We don't need that. So this is basically the same. So we can go in here, just copy that. And yes, I could use the other class as well, but I want to have things more structured. So this is for the connection. What we also need is a node. So let's go in here and create a new node. And it needs to extend the it needs to implement the comparable interface. Basically, we want to compare to other nodes by taking the x value, so we know if it's coming after or before a other node. So we are going to store actually different data in here, and what we're going to store is we're going to store the x value. So we don't need the y value anymore because it's just for calculations. What we also need is wait, let me think for a second. We need the output, so private double output. And the last thing that we need is we need an array list of connections. So this is new. In the old gene we didn't have an array list of connections, but this is necessary now. So we know where it's we know the connections to this node. So it's connections. It's a new array list. Basically, the constructor is only taking the x value, and the rest is going to be done later on. Let's also create some getters. Getter, and we need the x value, the output, and yeah, let's do it for everything. And let's also implement setters. So setter of that, and that. Okay, so the next thing that we want to implement is a calculate method that calculates the output by taking all the connections. And if you haven't seen the first video of my neural networks video, you should probably watch that. It's like basic calculations of nodes and networks and so on. Basically, if you don't have to watch that, you can also just follow along this video and I'll try to explain it. So let's create a Boolean method calculate, and I'll explain later on what the Boolean value is for. So let's first calculate the sum, and the sum is basically the sum over the input of the output of the previous nodes times the weight of their connection. So for connection, C in connections, you're going to check if it's enabled or not. So if C is enabled, then S is increased by C.getWeight times C.get from .get Wait, don't we have that? Oh yeah. Get. Okay, in here we don't have node genes anymore, but we have nodes. So we need to make sure that we are storing nodes in the connection, not node genes. So let me fix that very quickly, like that. Okay, good. Now we can go in here, get the from node, and get the output, or just get output, like that. Okay, the next thing that we need is we need some kind of activation function. In fact, you don't really have to use activation functions, but it's recommended. It also doesn't matter if it's like the sigmoid function, the relo. We are not going to use any gradients or so just use whatever you like. I'm using the sigmoid function for now because I know that it's going to work for my purpose. So private double activation activation function, giving a x value, and this is not the same x value as this, by the way. This is like the place on if it's an input node, output node, or in the middle or whatever, and it's just like it's the sum of the previous nodes times their connection. So let's return 1d divided by 1 plus math.exponential of minus x. That should be the sigmoid function. So let's go in here and set the output to the activation function of the sum. Okay, so this is almost it for the node class. The only thing we need to implement is actually the compare method that comes from the interface. So let's go in here. Can I? Okay, no, I can't. Something seems to be wrong. So let me just figure that out. Okay, so it seems to be. Oh, I removed the name for some reason. So it's node, I believe. Yeah, node. And we need to implement the compare to method. So basically, we want to compare to another node, and it's very simple. If the x value is if this dot x is greater than o dot x, then we return 1. Otherwise, if this dot x is smaller than o dot x, we return -1, and otherwise we are going to return 0. It's the same x value. I think this is not correct. I need to swap these. I just checked in my code, so we need to change these. So we return -1 if this is greater, and otherwise we're going to return 1. Okay, so this is actually it for the node class, except we need to return something, and we're just going to return true. And actually, we don't need that. I think we can just set it to void. Okay. Okay, now the next thing that we need is in the connection class, there's nothing we have to do, but we need a new class. It's the calculator. Okay, so the calculator is a little bit it's a little bit messy, but we need to have this. So it's actually like the idea is pretty simple. So what we want to have is we want to have a class, and we can give it a genome, and it takes the genome and it can calculate. Like we can feed data into this calculator, and he can calculate the output by taking the genome. Okay, so how are we going to do this? The first thing we need to do is we need to store some variables. We're going to store the input, output, and nodes in the middle. So private array list of node, and these are the input nodes, is equal to a new array list. Same for the hidden nodes and output nodes. So hidden nodes and output nodes. Okay, now the constructor is like a little bit messy, but we will try to do that. So the first thing is we're going to extract the data, so the random hash set of our node genes in our genome is equal to genes nodes, let's call it like that, equal to tree.get nodes. Same for the connections. So connection gene nodes like that, and cons tree.get connections. Okay. The next thing is we're going to use a hash map, because for each node gene we're going to create a new node, and we need to know where it's going to be stored in our hash map. So that's like we want to reference them, and it's a little bit quicker. So a new hash map from that maps integers to nodes like that. So let's call it this node hash map, and this is a new hash map like that. Okay, now we're going to go through every node and basically copy them into our nodes, into our input nodes, hidden nodes, or output nodes, and copy them into our node hash map and create new nodes in there. So for node gene, tree in nodes, or not tree, n in nodes, we will check some things. So it's nodes.get data. Okay, so let's first create a new node. Node is equal to a new node, and we take n.getx. Okay, the next thing is we want to put this into our node hash map. The node hash map dot put the n.getInnovation number and add the node. So this is pretty simple for now. Next, we want to check if it's an input, output, or hidden node. So if n.getx is equal, or let's say smaller or equal to 0.1, and it's a input node. So input nodes dot add the node. Else if n.getX is greater than 0.9, it's an output node. So output nodes dot add the node. And last we have the hidden node. So else hidden nodes dot add this node, like that. Okay, now the next thing that we want to do is we want to sort the nodes. So basically, we know that the input nodes and output nodes are sorted because, like, they're at the beginning. We cannot mutate them or anything, and we implemented it in a way that the first input, like the input nodes were at the beginning, and like right afterwards are the output nodes, and this is not going to change when we mutate them. That's like the way we implemented the method, and well, that's pretty important. So, but we need to sort the hidden nodes. We didn't ensure that they are sorted, so let's do that. So hidden nodes dot sort, and we need a new comparator. And the good thing is we can just call return o1 dot compare to o2. Perfect. So the next thing we need to also deal with the connections. So for connection clean c and cons dot get data. We want to extract the from node and the to node, copy the wake, copy the enabled and disabled state, and add it to our connections. So node from is equal to c.getFrom. Node to, do we already have that? Oh, it's node gene. Okay, no, it's actually, let's do it like this. So node gene 2 c.get2, and node from, that's like the calculation node, is equal to node hash map. That's basically where we store every node dot get the from dot get innovation number, and same for the to node. So basically we take the node gene, look in the hash map for the innovation number, and this one returns the node. So node 2 node hash map dot get 2 dot get innovation number, like that. Okay, now let's create a new connection. So connection connection con is equal to a new connection from the from node to the to node, not the from the node from, so the calculation node, and the calculation to node, so node 2, like that. Next we need to copy the wake, so con.set waked to c.getWaked, and con.set enabled to c.isEnabled, like that. The last thing, we need to add it to our connections. So it's this node 2 stores all the connections. So node 2 dot add dot connections dot get connections dot add this connection. Okay, pretty good. So basically this is it for the calculator constructor. The last thing is we need to actually calculate stuff, and this is pretty easy. So what we do is we create a new method, public double array calculate. So we give it a double array. If you haven't seen my network series, I explained this. So it's 3 dots. It's basically the same as an array, but it's very easy to use. So you don't have to create a new array. You can just paste the values in there without any brackets or so on. So if you have this, you can just, when you call the method, you can add any amount of numbers, and it's going to be used as an array. So I'm always using this when there's only one argument. It's an array. So I highly recommend that this is used. But you can also use the double thing, but this is easier to debug. Okay, good. So that's the first thing that we need to do, is we need to set the input to the input node. So for int I smaller, int I is equal to 1, I is smaller than input nodes dot size I plus plus, and we need to copy the, let's maybe first check if the input size actually fits the amount of input nodes that we have. So if input dot length is not equal to input nodes dot size, then obviously we have more or less nodes than input data. So let's maybe throw an exception. So throw runtime exception, and say doesn't work. Can I do this? Throw new runtime exception like that. Okay. Maybe too many nodes or too little. Data doesn't fit. Data doesn't fit. Okay, good. Now let's copy the data. So there cannot be any exceptions because we just checked that the input length is equal to the input node size. So input nodes at .get at I.set output. So basically the output of the input nodes is equal to the input to the network. So input at I. As I already said, this is the same as an array, so I can access them by using these brackets. Okay, the next thing is we need to do the calculations, and we ensure that the hidden nodes are sorted. So this is pretty good because this way we can just iterate through them, and this calculation stuff, like in the node we had this calculate method, we've got all the connections. And the thing is, assuming that they are sorted by their x value, we can ensure if one node is calculating the output of itself, all the nodes previously have already been calculated. So there's not going to be any node that hasn't been calculated yet. Okay, good. So the next thing is we are going to iterate through all the hidden nodes. So for node and in hidden nodes, we're going to call n.calculate. And basically the rest is just returning the output. So double output, double array, like that. Output is equal to a new double array, and the size is the same as the output nodes dot size. So for each output node we have got one output value. So for int I smaller than equal to 0, I smaller than output nodes dot size I++, and we simply copy the output value. No, actually we haven't calculated the output of the output nodes yet because they're not part of the hidden nodes. So we can also use this calculate method first. So output nodes dot get at I dot calculate, and then we can set the output. So output at I is equal to output nodes dot get I dot get output, like that. Okay, so in theory this should actually be it. We need to return the output, obviously. So return output, and we can also check if this is working. So if we go into the visual package, into the frame class, there should be a method, or there should be a button that's named calculate, but there's no code in there. So oh, okay, we haven't done that yet. So we should also do this. So in the genome class, we are going to have a calculator. So private calculator. And we need a method that creates this calculator. So public void create calculator, it's called generate calculator, and this is going to do nothing but generating the calculator. So calculator is equal to a new calculator by taking this object. Okay, good. Let's also create a method that calculates stuff. So public double calculate that takes an array as an input, array, and it's only going to call the calculator dot calculate. So if calculator is not equal to null, then we can call calculator dot calculate of the array. Okay, good. Let's otherwise return null. Okay, now we can use this. So the first thing, if we take this genome, we must generate the calculator, and then we can use the calculator to calculate an input. Okay, so if we go ahead, we can go into the frame, use this generate calculator method, and then print some data. So arrays dot, I'll write it again. So system.out.println arrays dot to string. So we are printing an array, And the array is the genome.calculate of, let's take some input data. Let's ensure that the input size is 3, so we need 3 values, say 1, 1, and 1. And we can check if this works. So this should be printed to the console. And if we go back into the neat class, into the main method, we should have an input size of 3. So if I run this should hopefully not crash. Okay, so this works. We've got 3 input nodes. And if I click on the calculate method, hopefully we should have an output of 0.5 and 0.5 because there are no connections. So the input to these nodes is 0, and the sigmoid activation function of 0 is 0.5. So if I run this, okay, it's returning null for some reason, and this isn't good. Let's maybe, okay. Okay, so I figured out where the problem is. And in the calculate method in our genome class, I forgot to actually return the output of the calculator. So we need to put the return in front of the calculator.calculate. Otherwise, we're just going to return null. So if I run this again, hopefully this should work now. So when I calculate with no connections, we should have 0.5 and 0.5. Now let's create a new link, and this has an input of 1. So if we multiply this by 0.47 with a minus sign in front, it should have an input of minus 0.47 roughly. So if I use the activation function, the sigmoid activation function on minus 0.47, it should be like, I would guess maybe 0.2 or 0.3. So if I run the calculator again, you should have 0.5 for the first one and something below 0.5 for the second one, and this looks pretty good. So if let's try it again with like a little bit more nodes. So let's create some mutations and check if this can calculate stuff, and this works pretty good, I think. And this should be it for this video, and in the next video we're going to implement the clients, and we're almost done with the series, and I hope you like it, and hope to see you in the next video.